Now let's look at the case where sigma is unknown, which is the more normal situation, because sigma known is not very common. So that's a theoretical case, and we build the formula on a theoretical basis assuming sigma is known, and then relax the unreasonable assumption that sigma is known into a reasonable one, which is sigma is unknown. So in that case, you replace wherever you had sigma, you replace that with S, and because we did that, we can't use Z, but we have to use T. Okay. And other conditions still are true, and that is X bar must follow normal distribution. So for X bar to follow normal distribution, you need to have a large enough sample, 30 or more. Okay. Or if that is not so, then we have to assume that the underlying population is normal, and we have to validate that by using either a box plot or the normal distribution QQ chart, histogram, and testing using the empirical rule, and so on. Okay. And then once you use T, the rest of it is very similar to the procedure we already looked at. And suppose we have an average cost of a hotel room in New York is said to be 168. To determine if this is true, is it 168? So which means equal to or not equal to 168, the null and the alternative hypothesis. And a random sample of 25 hotels is taken. So the n is 25, it's not 30 or more. And so here is a situation where we have to verify that the underlying population can be assumed to be normal, using the procedures I just mentioned. And it resulted in an X bar of 170 to 50, and a sample standard deviation, not sigma, S, is 15.4, and we want to test at 5%. So assume the population distribution is normal because of this. Okay. So mu is 168 against not 168, alpha is 0.05. So now you compute your T stat, plug in the X bar value of 170 to 50, 168, and you get 1.46 for T stat. Now we have to find the T table value instead of Z value. Now we have to have T table value, okay, for 0.025. So alpha 5%, 0.05, then 0.025 or the alpha over 2s. And remember, for T table value, we need to have degrees of freedom. And if n being 25, degrees of freedom is n minus 1 is 24. So we'll go to the T table with tail area of 0.025 and degrees of freedom of 24. So here 0.025 is the upper tail area, 24 being the degrees of freedom. You get 2.0639. So 2.0639 and a similar to minus 2.0639 on the left side. So those are the two critical values. If your T value is within this critical value, we cannot reject the null hypothesis. If it is outside, we will. And it turns out that it is within the critical values. So do not reject. You are not going to take a stand and reject. If you say 168 is the average value, okay, I'm not going to say anything. I'm not going to reject the null hypothesis because I don't have sufficient evidence to stand up and take a stand. Now, like in the case of Z statistic, in T statistic also there is a connection between a two-tailed test and the confidence interval. So you compute a confidence interval. If mean is inside the limits, then you cannot reject a two-tailed null hypothesis, a two-tailed test, and if it is outside, then we can reject the null hypothesis. Now the p-value approach is a little bit tricky here because T tables are such that it is very hard to find the p-value accurately. So for p-value, we'll purely use Excel functions. Excel functions will calculate the p-value correctly for us.